Alright class, this is 8.5, day 2. We're doing just word problems, fitting curves with data, and also figuring out word problems with using sine and cosine. So with these problems, all you have to do is basically sketch out all the information that's given, and then get your A, B, C, D value to create your equation. So we have a buoy that's bobbing up and down. The highest to lowest point is 3.5 feet. That is not the amplitude, because it's going from the highest to lowest in 3.5. Excuse me, so you need to divide by 2 to get that. And it says it goes from highest to lowest and back to highest every 14 seconds. They basically tell you the period right there. It is 14 seconds. So we can find the B value with that. Then it says find the equation assuming that it's at its equilibrium point, which means the midline or node line at t equals 0. So there is no phase shift, and there is also no vertical shift. So we have this graph that kind of looks like this. It's at its equilibrium point at 0 and it finishes at 14, and it goes down first. So I don't need to know these values, but it's gonna look like this. This curve's gonna look like that. If you divide 3.5 by 2, you get 1.75 and negative 1.75. So we almost have everything we need. There is no C and D value. We need the B value though. And if you remember correctly, 2 pi over b is equal to the period, which is 14 here. So if you do that, you get b equals pi over 7. So now all that's left is to write the equation. Always have y equals. This is a negative sine curve, so it's negative. The amplitude from 0 to 1.75 is 1.75. We said it was a negative sine curve, and then it's pi over 7 is the b value times x. And that's it. There's nothing else to do because there's no shift. So again, the key is write down everything you know and figure out how it matches up with the period, the phase shifts, the vertical shifts, if there are, and then the amplitude. Alright, so this one all you're doing is typing in numbers. So all you have to do on your home screen, which is like the main screen of your calculator, not into y equals, you just type in an 8 there, and you do the same thing for 15 or 17, sorry. And when you do that, make sure you're in radians, because we used radians when we converted the b value. Oh, I screwed that up. That should be 17. Okay. So when you type those in, I'm not going to go through all the typing because you guys know how to type things in the calculator. You get about 0.76 feet, and you get about negative 1.71 feet. Okay, so let's try one more. Again, it's very important you read everything. So after boarding a Ferris wheel, the gondola will reach its highest point 80 feet above the ground after 3 minutes. So I'm going to just sketch that. At 3 minutes, I'm at 80. So I'm putting a dot there. It then takes an additional 4 minutes, so we're at 7 minutes total. So 3 to 7 is 4, to get its lowest point, which is 4 feet off the ground. By the way, you can't assume you boarded the gondola 4 feet off the ground. That could have been on the side loading, so we don't know that it hits back here, and actually it won't, because you'll see that here. Don't worry about the 0. We don't know anything about that. All we know is at 3 it's at 80, at 7 it's at the lowest point at 4. So we have to write a sinusoidal function that models this. The problem is we only have half a curve. So you have to figure out where the curve will get back to its highest. Well, it should be a symmetric curve. So if it took 4 minutes to go from high point to low point, it'll take another 4 minutes to go from low point to high point. So that should be at 11. Now, be careful though. The period is the spacing between these two. So the period is not 11. It's 11 minus 3 or 8. Okay? Which means that our b value, 2 pi over b, is equal to 8. So 2 pi over 8 is pi over 4. So b equals pi over 4. So I have that one. I also have my phase shift. The phase shift is basically where you're starting when we decided to start the graph. And we know it's a positive cosine. The last thing we need to do is figure out this side here. Well, if you look at this, the gap between 80 and 4 is 76. And if you take half of 76, you get 38. Which means that it's a 38 and a 38 that splits this in two. When you get this have it, that is your A value. And then to find the middle line, which is your D value, where the middle line is, you add 4 plus 38, and we get 42. So the middle line is at 42. And so again, we look at the spacing, divide it into 2's. That's your amplitude, because 38 to go middle top and top middle bottom, and so on and so forth. So now we can write our equation. It's a positive cosine. We put a first, so that's 38. Positive cosine. The b value is pi over 4. We need a parentheses because there's a phase shift. It's to the right 3, so x minus 3, and then plus 42. And that's our equation. Then it says, how far off the ground was the gondola when the ride began? So it's saying when x equals 0, where was the gondola? So again, we're going to use our model and put a 0 in instead of an x. And make sure that this is all in parentheses for the cosine. And when you type that in, you find out that when you started timing, or when the ride actually began, you were 15.13 feet off the ground. And that's because with Ferris wheels, they load everyone. So you might have been like on one of the cars where, off to the side, and then when they finally started the ride where everyone was going around, you were up there. So yeah, that's that. The last thing we're going to do is type in data into our calculator, which you guys have done many times now. And this time we're going to use it to find a sinusoidal function. So I'm going to show you what the screen is, but then you're going to have to pause the video to type it in, because I already have it typed in. So if you get your calculator up, or out I guess, remember you hit the stat button, which is right here next to the alpha and x button, stat, and then edit. And when you hit enter, you should just enter your data as shown. Okay, so please pause the video now to take the time to do that, because I am going to go on. Okay, so now we have the data entered. You hit second mode to get back to the home screen. Go back to stat. Move over 1 over the calc menu, and just start scrolling down, because when we get to the bottom here, we'll find the regression we want. I think it's letter C. It is. It says sine reg. We want a sinusoidal regression. So we'd hit enter. All this stuff, don't worry about. Just go down to calculate, or just hit enter again if you don't get that menu screen. And then you'll see this equation pop up. Okay? We want to round to 2 decimals. So write the equation as it says here. So it'll be 3.52 sine parentheses 0.08x plus 1.78. On parentheses 12.56. Okay, so you can pause the screen here if you want, or you can come back and write the final answer down here. So 0.08x plus 1.78 plus parentheses plus 12.56. The last thing you have to do is what will the wolf population be after 10 years? Now you have to be careful. I didn't talk about this yet, but you have to look at your data table. X is in months, so this is 90 months. So it says 10 years. You have to use months because that's what this function's doing. And the wolf population is in thousands. So it's very important to notice that. So instead of 10 years, I want to do 120 months. Okay, so here's what we do. We say y equals 3.52 sine of 0.08 times 120. Plus 1.78, and then plus the, I don't know why I have an extra parenthesis there, plus 12.56. So we end up with that y is equal to 9.30, and then that is 1,000 wolves. And that is it. My computer is running out of power, so I'm going to cut it off here, and I will see you guys later.